Let's take a look at this example. This time we have 31 hundredths. Again, we're supposed to look at our weights and ask ourselves what is the highest weight which I can subtract from 0.31. I can subtract 0.25. That's why I'm going to write one over here. So I have 0.25 minus. So I'm going to have 11 minus 5 is 6, and I have 2 minus 2 is 0. Next, we're supposed to ask ourselves question, what is the highest weight which I can subtract from 6 hundredths? My answer is 0.03125. I have 0.03125. Perform the subtraction. I'm going to have 0, 0, 0. This is going to be 10, 9, 9. This is going to be 5. 10 minus 5 is 5. 9 minus 2 is 7. 9 minus 1 is 8. And I have 5 minus 3 is 2. We are going to retain only 5 bits after the binary point, and that number, that fractional binary number, is going to be approximately equivalent to 0.31. And my answer is going to be, I'm going to have 0, 0, 0, 0. Okay, and let me write this down over here. My answer is, as I said, this is not exactly 31 hundredths, but this is close enough at this moment for us. If you want to make the number much closer to this one, you're supposed to make sure that you are going to add some extra bits. Means you have to find the weights which are a little bit further from binary point and perform the subtraction and try to find the additional bits. But at this moment, if we are going to keep only 5 bits after the binary point, our answer is going to be correct. This time we're supposed to convert 375 thousandths to binary. First, you have to ask yourself question, what is the highest weight which I can subtract from this number? The answer is, I can subtract 25 hundredths. Perform the subtraction. We have 5, 2, 1, 0. Again, you're supposed to ask yourself question, what is the highest weight which I can subtract from this number? I can subtract 125 thousandths, right? So I have 125 and I have got 0. I subtract 0.25 and 0.125. Copy down the binary point, and if you have any weight which you didn't use, you're supposed to fill up this space by 0. And of course, don't forget about the 0 at the front of the binary point. Some problems ask you to keep 5 bits after binary point. So if you have situation like this, we're finished with the significant bits at the third place value, so we're supposed to just simply add 2 zeros. Okay, these zeros are not going to change the value of my answer, but are going to keep my answer with 5 bits. This time we're supposed to convert 7/10 to binary, and again look at the weights. The highest weight which I can subtract from 7/10 is 5/10, and I'm going to have 2/10. I subtract 5/10, that's why I'm going to write underneath of 5/10. From 2/10 I can subtract 125 thousandths. Okay, and I'm going to have 0, 0. I have 10, 9, this is going to be 1, 10 minus 5 is 5, 9 minus 2 is 7. I got 0.075. My question is, what is the number which I can subtract from 75 thousandths? I can subtract this value, and I'm going to have 0.0625. Subtract, and I have 0. Borrow 1 from here. I have 10 minus 5 is 5. 4 minus 2 is 2. 7 minus 6 is 1. Next, please notice that this value is lower than our lowest weight on the board. We said that we are going to keep 5 bits after the binary point. That's why my answer is going to be 0 point, and weight, which I didn't use, I'm going to mark by 0. Okay, let me rewrite the answer one more time. My binary answer is 0.10110. I got 5 bits. This number is not exactly 7/10, but is close enough that I can say that this is the solution to my problem.